And I'm sure the creator of the house doesn't really care because he built the house in 1935. He sold it. He's probably dead by now. You know, but we build software, and we have to care about whether things work down the line for our users. So, what do we do when things don't go quite right? And how do we know whether they're going right? So, you may write tests, you may have QA, but your test might not catch the bug, your QA might not catch the bug. The bug may be the result of a state you didn't even anticipate, which is why you never wrote a test for it. And it might not even be a software bug. It may be some type of UX thing where your onboarding flow is just a little weird and you're losing a lot of users because of it. So let's take a look at how an old school monolith would do this, because I'm talking about an old school monolith where you've got this one application that runs on one server, has a database. You interact with it via some HTML that it generates. We have a form submit that's sent up to the server. So this is really, running on one machine. There's nothing running on your computer. And the traditional way to get some logs out of that was just, append a line to a file. And if there was an issue, we kind of grep through that file, try to find the timestamp, try to find what's going on. No stack traces or nothing. We just see what methods are running there. And this isn't a great way to do it even for a monolith. But when we start talking about having multiple computers and we have to aggregate logs from all of those, we can't keep those logs on the computer. So how do we do this on the client? And this is code I wrote all the time. I write a try-catch block because I know this is going to fail every once in a while. And something fails, so I catch it, take the error, I console log the error. This way, when I'm writing the code, I can have my console open, I can see if it's throwing errors. But the problem is, I don't see that on the user's machine. So a user could call me and say there's something wrong with your app. I clicked something and it didn't work. Then I tell them, hit Command-Option-I, take a screenshot of what you see in the console. Hopefully they were able to find the console and send me a picture of that. But that's really not a great way of doing it. So what we're realizing is that our client applications are changing. They're not the same applications that we used to write when we were just generating static files and using form submits. As we're running more code on our clients, our front-end apps start to resemble a distributed system more and more, because we literally have these little apps running here and there, on thousands of people's computers at the same time, and we want to be able to monitor and make sure that all those apps are running properly. Fortunately, this means that we can learn from some of the principles that are used to monitor distributed systems. So let's take a look at the server side of this equation, microservices. How do we log and monitor our microservices, make sure that they're online, make sure that we can actually make a call to that microservice? And this is a basic little architecture diagram. I just found this on Google somewhere. But we have a couple applications. We have a logging service. We have a database. And this application, if you want to know if this one's working, we can check to see that it's online. And then we can also build reports based off of this and say, this kind of error occurs generally a couple times a day. It started at this point. We haven't seen it in the past week, so hopefully you patched it. But this lets us have a central dashboard to really reason about what's going on in our apps, what's working, and what isn't. Oh wait, whoops, wasn't supposed to go there yet. All right, so how do we do this on the client? So number one, that big long file with lots of things appended to it, that's basically what this is over here. We've got lots of different errors. That's a network error, some weird thing. The funny thing is, most of these are actually from third-party libraries that we pulled in from NPM. We actually have very few errors that are actually thrown by our code, but there's just little things that keep getting thrown from these weird libraries that we pulled in. And the cool thing about this is that we're able to see, this last happened an hour ago, this first one over here. It started 3 months ago, and we can see how often it occurs. And if we drill down a little further, we can see what browser it was, all of this information about the user, and what conditions the app was in, what state the app was in when it threw this error. So we can look at our Redux actions, we fetched a cause, we logged an analytics action saying that the cause page was viewed, and then with the Redux plugin, we're even able to look through the state. And obviously user data might end up in there. There are ways to filter out data that you know is going to be sensitive to make sure that doesn't get sent up to your logging service. These logs are also deleted after a certain amount of time to comply with GDPR. But this is one way to see things that are happening in your app. So this is something I realized very early before we went to production that we needed to add. And we added it, and we saw errors happening every once in a while. We were able to respond accordingly and get those bug fixes out. But then we started hearing through our support chat about some other errors that people were having. So this is one thing that I've recommended to a couple organizations at this point, and I recommend you do it in your organization too. If you have a chat box on a user dashboard or somewhere where users interacting with the app, throw every one of your developers on that chat box at some point. Meaning, maybe it's once a month, they have to spend 3 hours answering user support questions. They'll get a much better idea of what problems the users are running into and how they can better improve the app. So I started doing this. Even though we have a dedicated support guy, I started answering some customers' chats. They tag me on them all the time. And I started to notice that there's some weird things that I need to get a better view of what these users are experiencing. One of these issues that we were having is, this is a crowdfunding platform. We had a lot of donations that just weren't going through. And users were insisting, my card number's correct, everything's right, I double checked it 10 times. Very often we just call them, they give us the information, we put it in, and it worked every time. So I was really puzzled, what is going on here? What's going wrong? And then I saw an ad on Facebook for a cool new service called LogRocket. Anybody here use LogRocket before? Sweet. LogRocket uses an API that's available in the browser these days called Mutation Observer. And what Mutation Observer lets you do is listen for any changes that happen to the DOM and reproduce and log them, or do some action accordingly. So LogRocket essentially saves every change that has happened to the DOM, records it as breadcrumbs over time. It also has a Redux plugin, some other state management plugins, so that you can correlate the changes in the DOM with the current state of the app. And that gives us something like this. Oh, let's see. Let's see if it'll work. Come on. Cool. Here we go. All right. So it allows you also to hide fields. So you won't see their password. He's having an issue logging in. But we get to really see how they're interacting with our app. This is much better than even something like Hotjar that gives you heat maps and mouse tracers. But we can even dive even further in, and we can see there were some errors over here in the developer console on the right-hand side. I don't know if that's big enough. Let's see if I can get that a little bit bigger. Yes, over here we've got uncaught type error. Failed to execute read as data URL on file reader. That's when somebody drops something onto the drag and drop image uploader and it's not a valid image. So this gives us a really good view of exactly what they're doing, how they caused that error, and based on that we're able to plan how to make the user experience better for them. But at the top over here we also have network requests. And we can zoom in on what the user was doing at the time and also view the information that's being submitted. So one of the other issues that we were having in the app was multiple donations. We noticed that somebody was donating to a cause and the donation was going through 5 times. And that's not good. You donated $100. Now all of a sudden $500 is pulled out of your bank account. From our standpoint, that's not good. For the organizations, you're probably not going to make a chargeback on 400 of that. You're probably going to say the whole 500 is fraudulent, I want it all back, and then that organization loses money. And it's inconvenient for the donors because they have to deal with all of that. So I was able to get this on the page, on the donate page, find a cause that was happening, and I just sat there with a couple beers and paged from one session into the next, and just watched everything that the users were doing. And I saw somebody who filled out the credit card form, it failed. They deleted everything, filled out again, and it went through, and I was like, perfect, I got the perfect use case here. Like this is what I need to see. And I had blocked parts of the network request because I didn't want to see people's credit card numbers and stuff like that, but an expiration date and a CVV and a zip code are useless without the credit card number. So we were still recording that information. And I noticed that when Chrome autofills the field, even though the field only accepts 2 digits, Chrome autofills a 4-digit expiration year. Our payment service, even though they didn't know it themselves, I told this to them afterwards, they didn't know that they couldn't accept a 4-digit expiration year. So we went and wrote a little function that changed the 4-digit expiration year to a 2-digit expiration year, and we no longer have an issue with donations failing. So this is something that can really improve the way you're able to react to the way a user uses your app and make the user experience better for them. It also makes it much easier for you to tell, does my app actually work properly under the actual use case that the user uses it for. So obviously I can recommend these tools. They're very easy to set up. If we go to their quick start guide over here, zoom in a little bit, it's to just get the basic recording in your app, npm install -save logrocket, import logrocket.init, and give it your app ID. It shims console log, it shims XHR request, it shims all these different things that I can record that data. Yeah, that's about it. Hopefully you guys learned something about how to monitor your clients, make sure that they're working properly, and make sure that your users are getting the experience that they deserve. Thank you very much.